The ocean covers 71% of our planet. But we have explored less than 20% of it. That means 80% of Earth remains completely unknown to science. And in just the last 2 years, discoveries have been made that are rewriting everything we thought we knew about the sea. Not small discoveries. Discoveries that change the textbooks. Discoveries that could reshape our understanding of life itself. This is the story of the latest research on Earth-ocean elements. The discoveries that most people have never heard about. Discovery number 1. Dark oxygen. And this one is truly groundbreaking. In July 2024, scientists at the Scottish Association for Marine Science published a paper in Nature Geoscience that stunned the scientific community. They discovered that oxygen is being produced in the deepest parts of the ocean, in total darkness, where photosynthesis is impossible. For over a century, science believed that all oxygen on Earth came from photosynthesis. From plants and algae using sunlight. That assumption was wrong. At the bottom of the Pacific Ocean, 4,000 meters below the surface, something strange is happening. The seafloor there is covered in small black rocks called polymetallic nodules. They look like potatoes scattered across the abyss. These nodules contain metals like cobalt, nickel, copper, and manganese. And they produce electricity. Enough electricity to split seawater into hydrogen and oxygen. A natural electrolysis process happening in complete darkness. The oxygen levels measured in these deep-sea chambers were more than 3 times higher than the surrounding water. This is called dark oxygen. And it changes everything. It means life on Earth may not have begun with photosynthesis. It may have begun in the deep ocean, around these natural electric rocks. It also means that deep-sea mining, which targets these very nodules, could destroy the planet's primary deep ocean oxygen source. The debate over dark oxygen is still ongoing. Scientists are sending robots in 2026 to verify and study the phenomenon further. But one thing is already clear. The ocean is far more alive and active than we ever imagined. Discovery number 2. A record-breaking year for new marine species. In May 2026, the Ocean Census Program announced that marine scientists had discovered 1,121 new species in a single year. That is a 54% jump in annual species discovery. The highest number ever recorded. These are not just small organisms. They include corals, crabs, shrimp, sea urchins, anemones, and fish living at depths of over 4 miles. Among the most remarkable finds is a ghost shark, called a chimera, discovered in the Coral Sea off the coast of Australia. Chimeras are distant relatives of sharks and rays. They diverged into their own evolutionary lineage nearly 400 million years ago, predating dinosaurs. Off the coast of Japan, scientists discovered symbiotic bristle worms living inside glass castles made by deep-sea sponges. These worms have evolved to live inside the crystalline silica skeleton of the sponge, a structure that looks like something from a fantasy world. In the Pacific Ocean, researchers exploring the Clarion-Clipperton Zone found 24 new species of amphipods, tiny crustaceans that thrive in complete darkness. One of them was named after a character from the video game Hollow Knight. Off Argentina, a remotely operated vehicle explored the Mar del Plata Canyon and captured images of around 40 organisms that may be entirely new species. The expedition was live-streamed and attracted over 1.6 million daily viewers. And off the coast of Chile, scientists discovered a bright red fish that uses its fins like hands to walk across the seafloor. Each of these discoveries reminds us that the ocean is still a frontier. The age of exploration is not over. It has just moved underwater. Discovery number 3. The Atlantic Ocean current system is slowing down, and it could change the climate of Europe forever. The AMOC, or Atlantic Meridional Overturning Circulation, is a massive conveyor belt of ocean water that moves heat from the tropics to the North Atlantic. It is one of the most important climate systems on Earth. And it is weakening. In April 2026, a study published in Nature Communications found that the AMOC is significantly more likely to collapse than previously thought. The research showed that the current has weakened by roughly 1 spheredrop per decade since 2004. A spheredrop is 1 million cubic meters of water per second. Losing one every decade is enormous. If the AMOC collapses, the consequences would be catastrophic. Winters in Europe could become as cold as Canada. Sea levels along the U.S. East Coast would rise rapidly. Monsoon patterns in Africa and India would shift dramatically. The Amazon rainforest could dry out and turn into savanna. But the science is not settled. Some studies from Woods Hole and Caltech suggest the decline may be more limited. What every study agrees on is that the AMOC is changing. And we have only been directly measuring it since 2004. That is barely 22 years of data for a system that operates on timescales of centuries. Ocean scientists are racing to deploy more sensors, more monitoring arrays, and more robotic gliders to track these changes in real time. The ocean conveyor belt is one of the most critical systems on our planet. And we are only beginning to understand how fragile it truly is. Discovery number 4. The deep sea has revealed new forms of bioluminescence that scientists never knew existed. Bioluminescence is the ability of living organisms to produce light through chemical reactions. It is one of the most common forms of communication in the deep ocean. In 2025 and 2026, researchers discovered several new species of jellyfish, comb jellies, and sea worms with never-before-seen light displays. One species, a deep-sea jellyfish found off the coast of Brazil, produces a rhythmic flashing pattern unlike anything documented before. Another discovery involves a species of marine worm that produces bioluminescent mucus, creating a glowing cloud to confuse predators. Scientists estimate that up to 90% of deep-sea creatures produce some form of bioluminescence. We have only catalogued a fraction of them. The chemical compounds behind bioluminescence are being studied for use in medical imaging, biosensors, and sustainable lighting. Nature has already solved problems that our best engineers are still working on. Discovery number 5. New hydrothermal vent fields have been discovered, and they are teeming with life forms that should not exist. Hydrothermal vents are cracks in the seafloor where superheated water rich in minerals erupts from Earth interior. The water can reach temperatures of over 700 degrees Fahrenheit. The pressure is crushing. There is no sunlight. Yet these vents are surrounded by some of the most densely populated ecosystems on Earth. In 2025, explorers discovered a new vent field in the Pacific Ocean near the Galapagos Islands, the same region where vents were first found in 1977. The new field, named Sentry Spire, contains chimneys over 60 feet tall, covered in white tube worms, orange snails, and blind shrimp. These creatures do not rely on sunlight. They rely on chemosynthesis, converting chemicals from the vent fluids into energy. Some scientists believe that life on Earth may have originated at hydrothermal vents. The conditions there mirror what early Earth was like. If life can thrive at 700 degrees in toxic chemical soup, it changes how we think about life elsewhere in the universe. NASA studies hydrothermal vent ecosystems to understand what alien life might look like on Europa or Enceladus, moons with subsurface oceans. The discovery of Sentry Spire in 2025 is a reminder that we still have not mapped most of the ocean floor. New vents are being found every year. And every single one is a window into a world that operates on completely different rules. Discovery number 6. The chemistry of the ocean is changing in ways that scientists did not predict. New research published in 2025 and 2026 has revealed that microplastics are now present in every part of the ocean, from the surface to the deepest trenches. Microplastics have been found in the lungs of marine mammals, in the tissues of fish that live 6 miles deep, and in Arctic sea ice. One study found that 90% of seabirds have microplastics in their digestive systems. But there is a more surprising finding. Some bacteria in the ocean have started evolving to break down plastic. In 2025, scientists identified a new species of marine bacteria that can digest polyethylene terephthalate, one of the most common plastics. This is evolution happening in real time. The ocean is adapting to what we have done to it. Ocean acidity has also increased by 30% since the Industrial Revolution. This affects every creature with a calcium carbonate shell, from corals to plankton. Coral reefs around the world have experienced their fourth global bleaching event, the most widespread on record. But there is hope. In 2026, scientists successfully restored a section of the Great Barrier Reef using heat-resistant corals bred in laboratories. These super corals survived temperatures that killed other colonies. It is the first proof that active intervention can help reefs survive climate change. The ocean is not a passive victim. It is a dynamic, living system that is responding to everything we throw at it. The question is whether it can respond fast enough. 7 discoveries. 7 windows into a world that most of us will never see. Dark oxygen produced by electric rocks on the seafloor. Over 1,000 new species discovered in a single year. An ocean current that could reshape global climate. Bioluminescent creatures with light displays we have never seen. Hydrothermal vents with life that defies everything we know about biology. Microbes that have started eating our plastic. And corals that scientists are teaching to survive a warming world. Every single one of these discoveries was made in the last 2 years. Most of them in the last 12 months. The ocean is not silent. It is not empty. It is the most alive place on Earth. And we are only beginning to listen. More people have been to space than have visited the deepest parts of our own ocean. Imagine what else is waiting down there. This is Universal Impact. Follow for more discoveries that change how you see the world.